with our super long title, we're going to take the standard form and change it into vertex form. And we'll use two. Well, there's an algorithm called completing the square, which we'll focus on. And then formulas would technically get us there, but instead we'll use them as just a way of checking. But technically we can use either of them to get there. So as per the name, standard to vertex form, we should really look at our general functions for the two. This is our question. And our first key is figuring out which form it is, which you told me, it's in standard form. And I'm going to relate it to the general equation of a standard form. So all that means is what are the letters we use to represent the variables in standard form? A, B, and C, exactly. So one of the key pieces here is just being able to recognize which coefficients, and a coefficient is a number in front of a variable, and what constant represents C. So A and B need to be coefficients. So in this one, 2 is our A, negative 16 is our B, and our constant happens to be 15. Okay, that's actually important for completing the square, figuring out what those are. They're also very important because I'm going to write down the general form of vertex, which is A x minus, I don't have that many colors, so we're going to have to use blue again, and plus K. Okay, so I also have 3 letters that represent different constants or variables in the vertex form. Now, notice I use C and K. They got the same color, but they are a different letter. And essentially what that's communicating to us is that these are not the same number. There's going to be something that we do that's going to change these. Same with B. B and H, they're not the same number. They represent different ideas. But A is. And that's telling me that my A should be the exact same A in my vertex form. So right off the bat, I go, I already know that number's 2. I don't have to do any extra work to that. This is also important to do because if you look above, we have 2 little formulas. And H here, and we're going to say what H represents, it's actually the X value of the vertex. It's also equal to that, our H value. So I'll put it in blue. Hello, miss. Can I help you?
Where's your...
Right there. You can take the whole thing, okay?
No, where's your best one?
Oh, I don't know. This one's really good. Okay.
No, it doesn't have eraser.
Oh, take a eraser then. There you go. The formula is equal to negative b over 2 times a. So being able to tell what the coefficients are important for actually using this formula. Similar to, you've done quadratic formula? Yes. Same idea as quadratic formula. There's an A, a B, and a C. We just got to make sure we know which is which. The K value, which is also the Y value of the vertex, those two things are equal, is equal to this little formula, which we can pull out of the standard form. So essentially what we're doing, let's see, I said was green, B is our blue one, and A is our red one, okay? So what we can do is we can either complete the square, which we're going to do, and to turn this standard form, so this is the general form, into this form for vertex. The other alternative is taking these numbers, plugging them in, getting a X value of the vertex or the H number, plugging it in, and getting those same numbers from our standard form, putting them through the formula, and getting a K value or the Y value of the vertex, and plugging it in. So we'll use that as maybe our check. So for completing the square, our very first step is to actually recognize what our A value is. And what we're going to do is we're going to divide the first 2 terms by that A value. So that's our very first step. Okay, so we'll just do a little common factoring here. So when we do that, the A value comes outside of a set of brackets. And then what's left inside should be X squared. And though there's no number here, think of it as 1. Really the goal is to get, to get that value of 1. And that's why we divide by our A value. And then that will be minus 8x plus 15. So we common factored out. And the very first thing we want to notice is we just got an A value outside of the brackets. We're already building towards that vertex form. The next step here is a little bit of a formula. We have a new B value. So I might label it, because we already have a B, I'm going to call it B with a little subscript n. Just say our new B value, we actually have to divide that by 2 and then square it. It's going to be important that we do that because we're going to use that to build a perfect square trinomial. That's essentially what our goal is. So currently our new B value, so Bn we'll call it, is negative 8. So if I put it through this little formula, on the side, this is negative 8 divided by 2 squared, okay? And when we put that through, negative 8 divided by 2 is negative 4. And we square it, we're going to get positive 16. So what we're actually doing is we're going to take both the positive and the negative value of 16, and we're going to put it into this bracket.
Okay.
So our next line reads y is equal to 2. The rest of the terms are the same, x squared minus 8x. And we're going to both add 16 and subtract 16. And plus 15. Now, first thing I want to notice is we just did something to the right side of the equation, and I did not do it to the left side.
Mm-hmm.
So normally when we think of mathematics, something's gone wrong. We have to balance our equation. Whatever we do to one side, we have to do the other. But there's a very specific purpose to putting both positive and negative 16.
Because it would be 0.
Yeah.
So nothing would
So it's like adding 0 to something. And I could have done that over here, but it would not have changed anything. So that's really key. And the reason we do that's going to become clear in the next step. So what we've done is we've added 0 to a side, which doesn't do anything. So we can technically do that. Any equation you want in the future, feel free to add and subtract the exact same number as many times as you want. It'll probably get you nowhere, but it doesn't change the equation.
Right.
Okay, next step of the algorithm is that negative value. We actually don't want it as part of our bracket. We want to take it out. We want a trinomial. We want just 3 things in that bracket because we've been factoring trinomials. So we currently have this 4th term. I mean, we could simplify, but then we're back to square 1. We're going to pull this negative 16 out. When we do that, this coefficient has to be multiplied by it. There's a distributive property in math, so we have to make sure we multiply by it. So when negative 16 comes out, we got to multiply by that a value.
Mm-hmm.
So the next line will read y, still has that a value of 2. We should only have 3 terms within our side of our bracket, and it should be a positive 16. And the number that came out, negative 16 times 2 becomes negative 32 plus 15. All right, we're starting to look closer and closer. We have an a value. We have something in a bracket. It's not quite the same bracket as the vertex.
Mm-hmm.
And then we're pretty close to a k value. The k value is actually just simplifying that piece. So I'm actually going to do that in the next step. I know a lot of times teachers show you deal with the bracket. I want to piece together that we're almost there. We're going to keep this as a trinomial. And yes, we have to factor. But we're going to simplify this piece here. Negative 32 plus 15 is negative 17, I think. I think that's right. Negative 17. There's our k value. So we now have a k and an a. We're almost all the way to our vertex. This piece here, the teachers will show you usually a very quick shortcut to it. And it's because we've built something special. So I'll show you the shortcut, and then I'm going to just explain the idea behind it. The shortcut is taking the square root of the first term and the last term. So in this case, square root of x squared and square root of 16. And we find these 2 values.
Oh, I know. It would be like x minus 4 squared.
Ah, yes. Why the minus?
Because there's still like, I mean, there was like a negative 16. So if you like factor it, like if you do the whole like
Factoring
multiplication with the factoring, yeah, it'll also give you like the positive 16 and the negative 16.
Okay. In fact, what really tells us about our negative value is this middle term here. So what we're about to do is we're turning this trinomial into a binomial that'll be squared. Okay, and we'll talk about all the factoring. We're going to do it on the side after, but we're going to start with the shortcut. X squared, square root of it is just x. So that actually becomes the first term in the bracket. 16 square root is positive or negative 4. We're actually just going to use the absolute value. I just want, what's the absolute value of this? I just want the 4. The operator that goes in between is completely dependent on this middle term. So if that is a negative, then I use a negative. If that was a positive, then I'd use a positive in there. That's now our middle part. I bring on the rest of my stuff. Y is equal to 2, x minus 4 squared minus 17. We're in vertex form. I have an A, I have an H, and I have a K. So this is the algorithm to it. The tricky thing is here is, why did this work, this set of brackets? Why did that become a single thing? And we're going to do a little factoring on the side because it gives us some insight into this math. We had x squared minus 8x plus 16. Okay, let's just talk about factoring this alone. This is a coefficient of 1, so I can use my product sum. I could just a really nice shortcut to it. I need 2 values that are going to multiply to our c value, and they're going to add to our b value. Okay, so when I look at this, 8, 16, what multiplies to 16 and adds to 8? I know from doing my little shortcut here, the actual answer is going to be 4. 4 multiplies both of it to 16, and both of them add to 8, as long as I make them negative 4. And if you take a look, hey, that's exactly the value we got in here, negative 4. So when we go to do this, we're going to get 2 sets of brackets. Now, technically, I can do the decomposition and stuff, but because this is a letter A, I can go right to my end here. I'm going to have x as my first term in both, and negative 4 as my second term in both. Because the brackets are the same, I can just condense them to a single bracket and put a squared on it. And that's what gets us to our vertex form. This is known as a perfect square trinomial. That's where both of your factors end up being the same value. And if we just look at this as a quadratic, not the entire question we're doing, this quadratic here is the kind of quadratic that has a vertex on the x-axis. Not the one we're working on, but what we created. By adding, subtracting that value, we've created one of these situations.
So we made it into the perfect square trinomial.
We made the very middle part, not the rest of it. We made the middle part here into a perfect square trinomial by adding this little value here, the new b, when we divided it by 2, and then we squared it, and we added that term. This part here, x squared minus 8x plus 16, this is known as a perfect square trinomial, which allows us to factor into a single bracket that's squared. So that's what the whole point of this algorithm is trying to build this idea. And why build that idea? Because that's actually what the vertex form is. The vertex form is got a version where we have a set of brackets that are squared, and then we have some a and k value here. Okay, that's like a whole history of it. You don't really need to know all that. Just the algorithm is the key piece. So we'll practice that again. But just as proving that our answer is right, so we now have our vertex form, we should use our formula. So I'm going to zoom out for a second, take a look at where we've done all the writing. Okay, I'm going to write over here now. I'm going to bring there it is. Our original question, which was our y is equal to 2x squared minus 16x plus 15. And I'm going to write out those two little formulas. H equals negative b over 2a. And k is equal to c minus b squared over 4a. So I'm showing a lot of information in this one. Let's jump back over here. Okay. We knew our standard form. That's my a. This was my b. The whole negative there. And this was my c. According to my little formulas here, I can find the h value of vertex by doing this. H is equal to negative whatever the b is, and the b happens to be negative 16, divided by 2 times whatever the a value is. And the a value happens to be the number 2. So if we carry this out, on top we're going to get positive 16 divided by 4, and we're going to end up with h is equal to 4. Okay, that is the number we found in the middle. We'll have to go back into our general equation and see how it fits in. And the other thing we could do was the k value. K is equal to whatever the c value is, which in this case was 15, subtract a fraction. So we have to do a little bit of our fraction rules here. B was negative 16, and it is actually squared in this case. So if you notice here, we're taking this b value and we're inputting or substituting in negative 16, and then we're going to square it. And on the denominator of this fraction, we have 4 times whatever a value was, and we already discovered our a value happened to be 2. This one's a little trickier to carry out, but if we memorize it and we've done enough of our algebra, we should probably get to it. We'll start with our squared. Actually, don't know what 16 squared is. Hey Google, what's 16 squared? 256.
16 squared is 256.
Okay, good. 256 divided by 8. So I have 15 minus 256 divided by 8. This will become 15. If we have our calculator, we can probably find this quickly. I think this is going to be, this definitely will go in. Is it 32? It is 316. It is 32 minus 32. 15 minus 32 ended up being negative 17. Those numbers might be familiar to you from what we got in our answer. But our key here is vertex form. Y is equal to, like we said, a x minus h squared plus k. Well, this was my k, this is my h, and the a value never changed. The a value should be the same. So if you recall, the a value was 2. I plug this in, x. The minus comes along. It's part of our equation. So we put our negative in there. Our h should be 4 squared. And our k should be negative 17. And if we zoom out, that is the exact same thing we found here. We went through a big long algorithm called completing the square, and we got to that answer. Or we memorized 2 formulas, kind of like quadratic formula. You could call these Vertex formulas if you like. We plug into those, and we end up at the exact same answer. You can use them to check each other. You can just use one of them. If your teacher specifically wants to see that you go through this long algorithm called completing the square, then you can kind of use this as a check. I mean, it is extra work, but if you ever get stuck and you're unsure if your answer was right, we can use this as a way of checking our answer.